Okay, so I'm going to post these solutions, but what you would have done for homework last night was say, okay, number 19, the bottom is larger, so it's y equals 0. For number 20, the top is larger, and you didn't have a rule for that. You were just supposed to write the problem down and say, it's not horizontal, because it's not. 21, it's bigger on the top, so you can't answer that. It doesn't have an asymptote. So 21, no horizontal asymptote. 22, same degree is the ratio, so -1 over 1, y equals -1 is the short answer. 23, the bottom is bigger, so that's the one Diggs gave the rule for, y equals 0. 24, same degree, y equals a half, 1 for the top, 2 for the bottom. 25, same degree, 2 over 1. 26, same degree, y equals -3. That's what we're doing every time, just comparing how fast they grow. Does that feel easy? 27, bigger on top, you couldn't answer that. We're going to do that today. 28, bigger on the top, we're going to do that today. 29, bigger on the bottom, y equals 0. Bottom grows faster, so it goes to 0. 30, bigger on the top, you couldn't answer that one, so no horizontal. It didn't have a horizontal one. 31, bigger on the bottom, y equals 0. 32, bigger on the top, so no horizontal. 33, bigger on the top, no horizontal. 34, last one, same degree, so we have -1 over 5, -1/5. So I'm going to post this. I've got some notes here about horizontal asymptotes, and what we talk about today is going to be oblique asymptotes or just slant ones. So we're going to look at those today. So any of those that we need to talk about further? Basically, you're just comparing. If they're the same, you take the coefficients. If they're not the same, then you have to check to see if the bottom is bigger, and then it's y equals 0. Today we're going to look at what if the top is bigger. Those are our notes. So let's look. Today we're still in 4.5. We're going to look at when the degree on top is bigger. And this is where we started. So in this section, we started talking about asymptotes. I said to you, what do you think is going to happen if you have, we looked at some examples like this. If we have x to the 5th over x, we said it should look like x to the 4th, because if you divide them out, and the ones we looked at were more complicated than this, but it should look like x to the 4th, because that's what division means. So that would be in behavior. Then we said, well, what if on a similar note we said x to the 5th over x cubed? If you divide that out, it would look like x squared. So it might have something happening, but at the end, it should look like an x squared. It should look like a parabola. This is going to make it have a vertical asymptote because we learned that in the first lesson, x cannot equal 0 because it breaks the denominator. But as far as what we did yesterday, when we compare the degrees, bigger on top or not, that's going to be about in behavior. But what's cool about this section in our book in Precalculus is that we only find asymptotes that are lines. Okay? And if we say x to the 5th over x cubed, x squared is not a line. X squared is a parabola. So we're not going to find this one. We're just going to say this one doesn't have an asymptote because asymptotes means lines. This one is x to the 4th. It's not a line either. So we're going to say it doesn't have an asymptote. It doesn't fit that rule. There is one case where the top is bigger that it is a line though. So this is our new rule, Rule 3. It's called Slant Asymptotes. And this is what I always called it growing up. The book calls it an oblique asymptote because that sounds fancy. I mean, as if asymptote isn't a hard enough word to remember, they go and throw oblique at us. It doesn't matter to me which one you call it. But what does that mean? It means that when we compare the degrees, if it's bigger by 1, it'll be a slant asymptote. So rule 3 is if the top degree is larger by 1, then we have a slant asymptote. So I want to show you on the calculator what that looks like. Looking at this, we're going to know 2 things. We're going to know that this is a rational equation, so it's going to have asymptotes. It actually has vertical asymptotes. It has one of them. That's going to be at 0. If you take out an x, if you factor out an x, it would be x times x squared plus 1. And x squared plus 1 doesn't ever equal 0, so at 0, it's going to have one asymptote. But what we're trying to figure out today is in behavior. So horizontal or slant asymptotes, they're going to be the ones that say y equals. So let's look. This is 1 degree bigger on the top. That's what we're doing today. 1 degree bigger. That line is pretty clear, isn't it? So we're only looking for asymptotes that are lines, straight boundaries. And so it can only be 1 degree bigger on the top for us to be able to find it. So I want to compare, I want to actually find the asymptote that seems to be this line right here. I want to actually find it. So I'm going to write this equation down on my paper. You write it on your paper, and we're going to see how to find the slant asymptote. So this function into this function, when we compare the degrees, it's bigger on the top. That means the top is growing faster than the bottom. So it's not straight because it's not growing at the same rate. And in order to figure out what that line is, we actually have to do the division. So we actually write it out. X cubed plus x. Actually, I'm going to skip a line so I have more room. X cubed plus x into x to the 4th minus 3x squared. I think I'm going to spread it out a little bit because I don't know how things are going to work out there. I skipped a bunch of degrees there, so I don't know. So when you divide, you always take the bottom one into the top one. So we're going to do this just like we did in long division a couple of sections ago. When we divide, we're going to divide the first one in. What do we need to multiply x cubed by to make it x to the 4th? Just x. So this is going to be x times x cubed is x to the 4th. And then x times x is x squared. So it does line up. I've just got x squared there. I just wasn't sure. I could have done it in my head, but I didn't. Okay, and I draw my line. What happens after I draw my line? Jack, what do I do? With long division. I haven't done the subtraction yet, right? So I do need to bring the negative 6 down, but first I have to subtract this so that it cancels and then subtract that one. Okay, so now I have negative 4x squared minus 6. Does x cubed go into 4x squared? Cubed, there's not enough. I don't have enough. So x cubed won't go into x squared, so I'm done. This is the remainder. How we've been writing the remainder is like this. We said negative 4x squared minus 6 over whatever we divided by, x cubed plus x. So what do? We took this and we actually divided. I'm going to write down something. I'm going to write this down separately so I can talk about it for a second. I'm going to write it as y equals. I'm going to write it just like it is, though, x plus negative 4x squared minus 6 over x cubed plus x. This is the quotient when I get dividing. The dividing part is not that bad. I think you can do that fine. What happens after that, it seems weird though, I can actually disregard this. Because when I'm talking about end behavior, I'm talking about as x goes to infinity. When x goes to infinity. And we learned a rule yesterday that says as x goes to infinity, what does this do? The bottom goes faster, right? And it goes to 0. So because I'm talking only about end behavior, not middle behavior, but really, really, really big numbers, this, as x gets really big, this goes to 0. This becomes x plus 0 for end behavior. And that will always happen with the remainder when you do long division. So this is the equation of this particular asymptote, and we're going to find some more. But I'm going to put that into my equation on the calculator so we can see it graph, because it's really cool to watch it match up as soon as I find out where it goes. Here. Okay, so this was a really simple one. It's going to be x. And now the blue line and the red line, as we go big, I mean, if I zoomed out, it would pretty much become the same line. See, it's the same line, and then right here it's different in the middle because that's middle behavior. But as we go to infinity, that x is like the boundary for my function. Want to try another? Good answer, because we were going to anyway. Okay, so let's do it again. In order to have a slant asymptote, the value on the top has to be bigger by 1. So on the bottom, at most, I might have x plus 1. Nope, x squared. So this is my new function, and I want to write everything I can about it. Okay, so that's what I figured, yeah. Okay, so this equation, if I'm talking about end behavior, I'm talking about the ones that say y equals. It's either going to be a flat asymptote or it's going to be slant. It can only be one or the other. It can't be both. Sometimes with the vertical ones, you found more than one. This can only have one. So when you compare them, you notice that the top is bigger by 1. So that means if I divided it out, I would have a linear function, a line, x to the first degree. So let's write it out. X squared plus 1 goes into 2x cubed plus 2x squared plus 3x minus 6. You try this one. Try it with long division and see what you get. And then I'll come back and we'll work it together. Let's look at this. So when I divide it out, I'm going to say x squared and 2x cubed goes, I need a 2 and an x. That'll give me 2 and x cubed. And 2x times 1 is going to go here. So I had to skip one to make them line up. Then you do subtraction and say that cancels. So now we have 2x squared plus x minus 6. We can divide again this time. We couldn't last time. But this time we can. We're going to say x squared goes into 2x squared because they have the same degree. I need another 2, but no x's this time. Then 2 times x squared is 2x squared. 2 times 1 is 2. Draw my line, change my signs. Cancel the first one. I'm left with x minus 8. And this is the remainder. That's the last thing I can do. X squared doesn't go into x. I don't have enough degree. So this looks like plus x minus 8 over x squared plus 1, but we just said, hey, when there's a remainder, when we're talking about end behavior, that just disappears because it ends up going to 0. It's just such a small little tiny thing, it doesn't do anything to my problem. So this is my new equation, and how do I write that? I write it as y equals 2x plus 2. So it's y equals because it's a slant one. It's not vertical, that's x equals. The slant ones and the horizontal ones are y equals 1. So I'm going to put this in my calculator and see what it looks like. So we're putting these in. I just asked the class if there were any vertical asymptotes here. What's 1 plus 1? 2. 2's fine. It's tricky. -1 squared is still 1. This is tricky because when you set this equal to 0, you get x squared equals -1, and you take the square root of -1, and there's not an answer. So this one doesn't have a vertical asymptote. Sometimes you have a fraction and there isn't a vertical one, and that's okay. My second line I figured out was 2x plus 2. I lost my remainder, so it's just this part of the equation. It looks like y equals mx plus b every time. You just drop the fraction. So back on my calculator, I'm going to put 2x plus 2, and they should match up. There's the function. It didn't have an asymptote, but it went off of the graph in the middle because that's middle behavior, and then the end behavior was it's trying to be that slant asymptote. Pretty cool, right? So what your homework for me tonight is, you've got these problems already worked out that were the ones we went over in class. The ones that, well, I don't have them here. They're here. So all the ones that you said, no, it's bigger, larger on top. So number 20, you need to go back and find the oblique asymptote for. So it's the same set of problems, but you're only doing the ones where it's bigger by 1 on the top. Does that make sense? So you'll have to look through them and pick them out. So number 20, you need to do, number 21 is bigger on the top, but it's by 2. So you don't have to do 21 because it's not a line. It's something else. You don't even have to describe it. You can just say 21, there's not a horizontal one. 22 we did. This one was 0. This one, 27, is bigger on the top by 1. This one is bigger on the top by 1. So that's what you're doing every time, okay? And you can start on that now. You'll be done in 10 minutes. So, yeah.